I'm not as think as I smart I am. I'm not as think as I smart I am. I'm not as think as I thought I might be, for that's clear anybody to see. I'm not as think as I smart I am.
Welcome to the Brainsmatter podcast. This is episode 4 for the 7th of November 2006. I'm the Ordinary Guy, and I'll bring you stories on astronomy, chemistry, physics, biology, humanities, and anything else that's interesting. Have you heard of chemosynthesis? It sounds a lot like photosynthesis, doesn't it? You probably know all about photosynthesis. That's where plants take sunlight and, using a substance normally found in the leaves of plants called chlorophyll, they take the sunlight, along with carbon dioxide found in the air, convert that to energy which enables the plant to grow. The great thing about photosynthesis is that the plants end up putting out oxygen, which is perfect for animals, since that's what we all breathe in. Of course, we breathe out carbon dioxide, which, in turn, the plants use. It's a perfect combination. So we can't do without plants, and they can't do without animals. But what does this have to do with chemosynthesis? Chemosynthesis is the same process as photosynthesis, but instead of using sunlight to convert into energy, the process uses chemicals, hence the name. It's also related to hydrothermal energy, and as you can figure out from the name, it's related to both water and heat. I'll come back to an explanation soon. Perhaps you've heard of the giant tube worm. The scientific name for this creature is the Riftia pachytella. The Riftia lives deep underwater, far too deep for sunlight to penetrate. It lives near hydrothermal vents deep on the sea floor. The Riftia has no mouth, no gut or digestive system as we know it. It's a huge animal. Imagine a tube worm 1.5 meters long and 2 centimeters in diameter. So if you think about it, how do these animals survive in a toxic environment? They have no mouth and no digestive system. Where do they get their energy from? The answer to this is chemosynthesis. The Riftias actually harbour bacteria within their body cavities. Bacteria in many environments, from the sea to those living on the surface of the earth, are well known to be able to use chemical energy as the basis of their metabolism. In the case of the bacteria living inside the giant tube worm, they convert the hydrogen sulfide, which is also known as rotten egg gas, into nutrients they can use. They then produce organic compounds that form the basis of nutrients, which the host, in this case the tube worm, can use. The bacteria use inorganic chemicals, such as the poisonous sulfides, and converts them into organic compounds that the deep sea creatures can use, and this is exactly what plants do with photosynthesis. They convert carbon dioxide, which can kill animals if inhaled in huge quantities, and they convert that to oxygen. Until this underwater system was discovered, scientists thought that all biological systems started with sunlight. Plants use photosynthesis to convert sunlight to energy, then those plants being eaten by animals, and then those animals being eaten by others, and so on. And this seemed to be true of the ocean as well, but now we know that biological systems can exist deep under the ocean's surface, where it's far too dark for sunlight to create enough energy for the whole ecosystem to survive. It's a very elaborate ecosystem that is completely independent of sunlight at any level of the food chain. So this brings up the question: can life exist deep within oceans in the further reaches of the solar system, beneath the surface of the moons of Jupiter and Saturn, as long as they have enough internal heat? Hopefully scientists can answer this sometime in the future. And now it's time for today's Brainteaser. Do you know the official name of the Oscar statuette from the Academy Awards? The answer to this later in the show. Piezoelectricity. No, it's not the electricity used in pizza ovens, but you can be forgiven for thinking so. It's actually electricity formed when certain crystals called piezoelectric crystals are placed under what's called mechanical stress. In other words, they have physical pressure put on them to either press or twist them. This property of piezoelectric crystals comes courtesy of the way the atoms in the crystal are structured. The crystal is electrically neutral but consists of interlocking domains which have positive and negative charges. The crystal is symmetrical, but when placed under physical stress, the symmetry changes and as a result it generates voltage. The interesting thing about piezoelectricity is that you can get electricity or energy from the most mundane sources. For example, a scientist named Sir Trevor Bayliss, who invented the wind-up radio, came up with the idea of using piezoelectricity in devices in your shoes. These devices would enable you to charge your mobile phone battery as you walked. How is this possible? Well, the shoes that Sir Trevor designed had a slot for the battery, and the piezoelectricity circuits would capture the energy that was discharged every time the wearer took a step. Each step produced around 8 watts of power, so after a few thousand strides the battery would then recharge. Not a bad way of getting energy at no cost. But this idea fell flat. After the World Trade Center in the US collapsed in 2001, the concept of electric shoes didn't get support, especially after the so-called shoe bomber Richard Reed, who tried to smuggle explosives on board a plane inside his shoes. Imagine trying to explain circuits in your shoes to customs officials today if you wanted to visit the USA. The concept of piezoelectricity, however, is a great one. Imagine harvesting what would otherwise be wasted energy. By walking, you could create enough energy to power small lights or audio systems. No more worrying about your iPod or mobile phone running out of battery charge. Technology isn't advanced enough to enable us to do this efficiently just yet, otherwise we'd look like a cyborg out of Terminator or a William Gibson novel. But in time, these ideas should become reality. Maybe one of the listeners out there will be inspired and become a scientist involved in bringing piezoelectricity to the market in a usable form. Now wouldn't that be something to write home about? Now it's time for the answer to today's Brainteaser. The official name of the Oscar statuette is the Academy Award of Merit. So how did it get the nickname Oscar? Nobody is 100% certain, but the popularly accepted story is that the Academy librarian at the time, Margaret Herrick, said that the statue looked like her uncle Oscar. That conversation was overheard by a journalist, who then mentioned the name in an article, and the rest, as they say, is history. The Academy itself first officially used the term Oscar in 1939. So what's been happening in the world of knowledge lately? Well, Gibson guitars have just released a digital guitar, one based on a networking protocol, Ethernet. This is what you find in most workplaces and homes, especially if you have a DSL internet connection. Rather than using the old classic analog signals, you may remember in the old days of not that long ago, amplifiers for guitars used to have big valves that looked like light bulbs. Then along came the transistor, and amps became a lot smaller, although people claimed that the sound wasn't as good. They were still analog guitars though. But now, with digital guitars, each string sends out a digital stream, that is, a string of ones and zeros. These are then converted by software inside the guitar to sound. You can connect it straight into your computer as well, but I don't know how it'll be taken up by professional musicians. According to new research, the Sun wasn't alone at the creation of the solar system. Leslie Looney and his colleagues at the University of Illinois in the US say that most stars in our galaxy were formed in clusters, and at least one of the Sun's siblings was a supernova. The group studied evidence found in meteorites. The decayed particles in isotopes of iron show the makeup of the early solar system. Apparently, the solar cluster from all those billions of years ago dispersed due to a lack of gravitational pull, and with the expansion of the universe, our Sun now appears alone. Looney told the Space.com website that if the Earth formed during the cluster environment, then it is likely that other celestial bodies would more than likely have planets as well. And this could mean life elsewhere. More information on this story can be found on the link on the show notes. NASA is currently on a push to return astronauts to the Moon by the year 2020. However, NASA has also known for a long time that with that goal comes danger, and that danger comes in the form of solar radiation. On Earth, we're protected from solar radiation by the atmosphere, so things like the ozone layer protect us from harmful rays. But in space, astronauts, cosmonauts and taikonauts don't have this luxury. By going to the Moon, the astronauts will be exposed to far more radiation than those on the International Space Station and during the Apollo missions during the late 60s and early 70s. Astronauts spent less than 2 weeks on each mission, which minimized exposure. NASA has guidelines for their astronauts on how long they can stay in space to minimize the risk of dying from cancer. This varies according to gender and age, but these risks need to be identified and investigated if we are to go not just to the Moon, but to Mars and beyond. No matter what we think, it seems that we're always at the mercy of the universe. Charles Darwin, the British naturalist who travelled the globe and brought the concept of evolution to modern society, had a missing notebook, which was thought to be stolen. Last month, Cambridge University scientists used a microfilm copy of those notes and made them freely available online, allowing visitors to view over 50,000 pages of his work. The link can be found in the show notes on the website. Thank you for listening to the BrainsMatter podcast for the 7th of November 2006. If you have any comments, questions or suggestions, please drop me an email at brainsmatterinbox@gmail.com or leave a comment on the website at www.brainsmatter.com. Please let me know where on the globe you live and how you found the podcast. Music on today's show comes courtesy of PodSafe Audio, and you can find the podcast by doing a search within iTunes or by subscribing manually by clicking one of the links on the website. Please leave comments and vote for the podcast in iTunes and Podcast Alley. I'll leave you with a couple of quotes. The first from Henry Young. If at first you don't succeed, So much for skydiving. That one's a little tongue-in-cheek, so on the same theme, but more seriously, here's one from Mary Pickford. If you have made mistakes, even serious ones, there's always another chance for you. What we call failure is not the falling down, but the staying down. I hope you enjoyed the show. Bye for now.
I'm not as think as I smart. I'm not as think as I thought I might be, for that's clear anybody to see. I'm not as think as I smart. I'm not as think as I smart. I'm not as think as I clever I would be. I'm not half as clever as me.